Warm good morning, dear class minors. Today we'll begin with the new topic of the same chapter, atmospheric pressure. So far we have discussed with the pressure exerted by the solid as well as liquid. Now today we are going to start with the pressure exerted by air or gas. So before we come to the atmospheric pressure, let us discuss the definition of atmosphere. Now, atmosphere is defined as an envelope of air which surrounds the Earth's surface, or a thick blanket of air which surrounds the Earth's surface is called atmosphere. And our Earth's surface is surrounded by air up to a height of 300 kilometers. And this air has got weight. As you know that air is considered as a matter. So this air has a weight, and this weight exerts a force on the Earth's surface. Air exerts a force or a thrust on the Earth's surface, and this thrust exerted by the air on the Earth's surface, we call it as atmospheric pressure. So since we know that pressure equals to force divided by area, so force we call it as thrust also. So when we define atmospheric pressure, atmospheric pressure is defined as a thrust exerted by the air for a unit area of the Earth's surface is known as atmospheric pressure. Now related with the atmospheric pressure, there is one demonstration of atmospheric pressure, that is a collapsing of tin can experiment. Now for that, we take a tin, you follow the diagram here, a tin can filled with water, okay, and this tin can is fitted with the airtight stopper. There is a stopper here, a cap, and this tin is filled with a water, a little amount, some amount of water, that means a 1/3 amount of water you can fill it, not the entire tin, half you fill it with the water and supply the heat and heat the tin can. And you heat the tin can in such a way so that the mouth or the mouth of the tin can is opened. Now, when you supply the heat, the water gets heated up, and after that it starts boiling. Okay, and the steam starts rising up. Okay, the steam will rise up. So once the steam will start coming out from this heated water, okay, immediately you will close the stopper. You will close the can, the mouth of the can, you close it. And after that, you will withdraw the heat, remove the heat, and pour cold water into this can. Into this heated tin can, you just pour cold water. Once you pour the cold water, the tin get collapse, or they will get crushed from inside. Okay, that means all the side of the tin can get crushed, or they get collapsed from inside. So how it happens is that initially what will happen is that now the pressure inside the tin can is equal to the atmospheric pressure outside the tin can, because outside the tin can the air will exert a pressure, which we call it as atmospheric pressure, air pressure. Okay, and initially the pressure inside the tin can, okay, and the outside the tin can is equal, they are same. But later on what will happen when you put the cold water, when you pour cold water here, now the steam inside the tin can will condense. Okay, the steam inside the tin can will condense and convert into water and water vapor. Water and water. Once you pour the cold water here, the tin gets condensed, it gets cooled. So once it gets cooled, okay, then what will happen? The steam will condense to form water and water vapor. So therefore, what will happen is that now the pressure inside the tin can will become much more less than the outside pressure. That means the inside pressure will become much more less. It will become less than the outside pressure. Now, why this pressure will become less is that because now the steam will condense into water and water vapor. So when the steam will condense or cool down into water and water vapor, the pressure inside the tin can will become very much less compared to that of the outside pressure. So therefore what will happen is that now the outside pressure, which we call it as the atmospheric pressure, will become more than the inside pressure, making the tin to get collapsed. So due to this atmospheric pressure exerted on the wall of the tin can get crushed. So this is how the collapsing of tin can occurs, and this demonstrates the atmospheric pressure. Now the next point will come to some consequences, some effects of the atmospheric pressure. Number one is the sucking of drink with a straw. Sucking of drink with a straw. Okay, now the first one. Now when you are provided with a water or a cold drinks, okay, in a glass, in a container, in a glass, the cold drinks or the water are filled here. Then on the top of that, the straw is immersed. And with the help of the straw, you suck the drink and it goes into your mouth. So how it happens? So before, when the straw, this is the straw, when the straw is kept or immersed or dipped inside the liquid or in cold drinks. Okay, so first it is dipped inside the cold drinks here, and you will suck the straw. Okay, you will pull the straw. So when you suck the straw, what will happen? The air inside the straw will come out from the straw and goes into our lungs. So that means the air will be removed. When you suck it, that means the air will be removed inside. The air will go out or come out from inside the straw. And therefore, when the air will come out from the straw and goes into our lungs after sucking, then what will happen is that the atmospheric pressure just over the liquid or the cold drinks will become more than the pressure inside the straw, because there is no air inside the straw, because the air has been pulled up with your mouth and it has gone into your lungs. So there is no air inside the straw. So therefore, when there is no air inside the straw, the pressure inside the straw will become less than the atmospheric pressure, and atmospheric pressure will be exerted. Atmospheric pressure will be exerted on this liquid, that is on the surface of the liquid. Okay, on the surface of the liquid, atmospheric pressure will be exerted, and therefore the atmospheric pressure will become more than the pressure inside the straw, which force the liquid to go inside the straw and it comes into your mouth. So this way, the atmospheric pressure, it helps in sucking the liquid from the glass or container. The next one is here, that is filling a syringe with a liquid. Filling a syringe with a liquid. So this is the syringe here. Okay, this is known as the barrel, and there is a plunger. Okay, you just pull it. Plunger is here. Now this syringe is also same as that. It also works on the same as that of straw. Okay. Now these syringes are deep inside the liquid. So when you dip inside the liquid, this plunger will pull down. We will press the plunger down. Okay? We will press the plunger down. And what will happen when you press the plunger down? What will happen? There is the air inside the barrel will come out through this tip of the syringe. Through the tip of the syringe, the air will come out. There is no air. Okay? And you will, first of all, what you will do is that you will just put the plunger. You press the plunger inside the barrel. Once you press the plunger inside the barrel, then the air inside this barrel will come out through the tip of the syringe. Then these syringes are pressed or put into the liquid, and slowly what will happen? You will pull the plunger up. Upward you will pull the plunger. So once you pull the plunger up, the liquid will start filling inside the syringe here. The liquid will start filling inside the syringe or inside the barrel. So how it happens is that now first when you pull the plunger down or inside, what will happen? The air inside the barrel will be removed. Okay, there will be no air. That means the pressure inside the barrel is very less, but the atmospheric pressure will be exerted on the surface of the liquid. So once you pull the plunger upward, what will happen? Now due to the atmospheric pressure outside, the liquid will be more than the pressure inside the barrel, and due to that atmospheric pressure, the liquid will fill inside the barrel. Okay, once you pull the plumber, and therefore the liquid will fill inside the Sikkim. So these are the consequences of the atmospheric pressure. Thank you.